23, 76 called spatial integers. So for this problem, we call a positive integer spatial if all of its digits are distinct. What does that mean? So for example, 12 is a spatial integer, but 11 is not. Because all of its digits is same for 11, because for this digit and this digit is same. But the definition is that all the digits are distinct. So 1, 2, 3, it is a spatial. 1, 2, 3, 4, it is spatial. But 1 to 1, it is not. Yeah. So giving a positive integer n, we're going to return the number of spatial integers that belong to the interval 1 to n. So this means inclusive. So from 1 to n, inclusive, we're going to check how many spatial integers. Definitely, we cannot use brute force because this is going to be a really big number. It's going to be 10 to the power of 9. Yeah, so this means we cannot solve it by using the brute force. So instead of using the brute force, we're going to use the digital DP to solve the problem. The digital DP is that we're going to check the numbers one by one. So instead of we're going to check the numbers from 1 to 20 in the first example, 1 to 20. So we're going to check each bit directly. So for 2 and 0, we have 2 bits. First of all, we're going to turn it into a string. So for this 2, how many choices? Can we choose 0? No, we cannot have leading on zeros, but we can choose 1 and 2. Yeah, we can still choose, but we cannot choose 0, but we can choose not to do anything, just not choose a number. So there are still 3 cases. Yeah. So for the 2, after that, it can only be a 0. So there's 1 cases. And what about nothing? If we are not choosing anything, so after that, it's going to be 1 to 9. So it's going to have 9 different cases. And what about after 1? So we can choose something from 1 to 9, but there is a duplicate. From 0 to 9, but 1 is a duplicate. Yeah. So we're going to accept 1. And how many cases? There are going to be 9 cases. So in total, it's going to be 1 plus 9 plus 9. It's going to be 19 different cases. Yeah. So programming going to be a little bit hard for the digit DP. So that is why we're going to use a template to solve the problem. Yeah. So let me first explain the template. So after using the template to solve the problem, let me explain what is the meaning of the template and why we can solve it like that. Basically, the reason is just dynamic programming. Yeah, because we reduce the time complexity from 10 to the power of 9 to just 100. That is why we can use memorization to solve the problem. Yeah. So first of all, we're gonna turn the integer n into a string because we just need to check how many digits. So there are 2 digits. We just need to check how many of them. Now we need to use memorization, and let me just define a DFS function. Inside, I'm going to prepare the index. So the index means from index 0, the index of the string from 0 to n. So this is the meaning of the index because we're going to check the each bit one by one. And then we're going to use a mask. So the meaning of the mask is that we need to find the distinct integers. By using the mask, actually, we are using a set. For example, for this digit, maybe for the first digit, if we choose a 1, for the second digit, can we choose 1? No, we cannot. This is why we're going to use a mask. Basically, it's a set. We're going to use this mask to check which number is chosen, which is not, to find all the distinct integers. We also need some other variables. It is called isLimit. So we can call it isLimit. IsLimit just means which number is the limit. For example, this number 2 is a limit. Yeah. So definitely after this number 2, the property is going to be definitely this means the number cannot be more than 2 for the first digit at here. It can never be 3 because 3 is bigger than 2. So this is why we're going to define isLimit to check if this is bigger. If 1, 0, 2, it is okay, but if it is 3, it is not. Yeah. So this is the meaning of the isLimit. And we also need to check another variable. It is called isNum. So isNum is just to check for the first number if it is chosen or not. So in the example here, so for the first place we didn't choose anything. So this is the meaning of isNum. This means isNum is false. So after that we can choose 1, but we cannot choose 0, but we can choose 1, 2, 3 until 9. Yeah. So this is the meaning of the isNum. If the isNum is true, so for example, if the first number is 1, this means isNum is true. This means always the previous num if it is num or not. So the previous number, it is a number, so this means isNum is true. So this means after that, if it is a 1, we can choose from 0 to 9 except 1. Yeah, because 1 is a duplicate. This one gonna be controlled by the mask. Yeah, so there are gonna be a lot of variables, but the coding gonna be just like a template. So if the index is equal to the length of the string, we just need to check this isNum. Yeah. If its num is true, we're gonna return a 1. If it is false, so for example, this is the return. If we go to the final number, this is a 2 and this is a 0. So if we find a number 0, now for here, this I gonna go out of the string. I gonna be equal to 2, and then we're gonna check isNum. If this is num, this is a number, 0 is a number. This means isNum is true, so we're gonna count it. This is a valid case. Yeah. So for this number 20, it is a valid case. So this is why we're gonna use isNum. Yeah. But if isNum is false, for the first person we didn't choose any number, and for the second person we didn't choose any number. Now I equal to 2, and isNum is false. So we're gonna code it. We're gonna check it as a 0 because definitely, yeah, with 2 underlined, it is not a number. It means we didn't choose any number, so we're gonna return a 0. So this is the meaning of isNum. Now we want to check if not is a number. Yeah. So this means from the beginning, it is this isNum is not chosen. Yeah. So this means not choose from here. So if it is not choose, so we're gonna update the not choose situation. So the result we're gonna set it to 0. So this means we will not choose a number. So I gonna plus 1, and the mask gonna still be the same. If we are not choosing the number, and this limit gonna be a false. Yeah. So for example, all the numbers less than 200. For the first one, if we are not choose a number, so after that, how many different cases? That is its limit gonna be set to false. This means after that, definitely we can choose 99. Yeah. Here is just for duplicate, but yeah, if it is not 99, maybe 98. But definitely there's a lot of different cases. So this is limit gonna be set to false. Yeah. And its number, because from the beginning this its number is set to false, so we're gonna still set it to false. Yeah, because this number is not chosen. It is not chosen, so we're gonna set it to false. If we choose a number, definitely we're gonna set it to true. Yeah. Now we're gonna use the low and high to control the range for the numbers. So for example, it is 20. For the first one, the low gonna be 1, and the high gonna be 2. Yeah. Yeah, because definitely for the first number we cannot choose a 0. So this is why we're gonna use this low and high to control it. So the low is equal to 0 if it's none. Yeah, this means for the first one, if we choose a number, for example 1, this means it's num. So after that, it's gonna have how many different numbers. So definitely for the low, we can start from 0. This means after 1, definitely we can choose a 0. If there's a nothing, so we have to choose a 1. So this is the meaning. So else we're gonna choose 1. And for the high, it's gonna be the integer of si if its limit. Else it's gonna be 9. Yeah. So the meaning from here is let me just yeah, for the first number, if we choose a 1, and then as I explained, the low can be 0. So what about this high? Yeah, because this is after the first number we choose a 1, so this limit gonna be yeah, let me think about it. Yeah, we cannot choose this int at I. We cannot choose 0. Yeah, because this limit is false, so we have to choose a 9 from 0 to 9. Yeah, because after this one is not a limit. The limit is of 2. Yeah, 2 is the limit, and 1 is not. Yeah, 1 is not the limit. That is why we can choose 9. So this means the low gonna be 0 and the high gonna be 9 for the second digit if the first one is 1. Yeah, because there are so many different situations, that is why we're gonna prepare so many variables for our function. Now let's just check the mask for all the digits from low to high. So here we're gonna use the +1. If this number is not chosen before, so we're gonna use mask. Right shift digit and 1. This means if this number is not chosen. So from the mask we have this digit and we're gonna right shift on the digit. For example, if this d is equal to 1 or 9, it's just right shift with that position. We just check if it is 0 or not. Yeah, if it is 0 means it is not chosen, so we're gonna choose it. Yeah, so we're gonna update it to the final result. So it's gonna I +1, and here we're gonna use the mask. Yeah, so it's gonna be mask add, and we're gonna need to choose this number. But how can we choose this number? We're gonna use the 1 left shift with d positions, d digit. And what about the is limit? So we're gonna still use the is limit. It is determined from the beginning, but we still need to use this because this is limit gonna be true from the beginning. We're gonna still use it, and we need to check this d, this digit, is this d equal to high or not. If it is equal to high, definitely it's gonna be true. So for example, currently it is 1. But if it is equal to 2, this limit is gonna be true because this is limit is true, and d equal to 2, 2 is high, so this means it's gonna be true. If it is a 2, so definitely the is limit gonna be true. Yeah. So for the next number, we have to choose a 0. We cannot choose all other numbers. This means the low gonna be 0, and the high gonna be integer of si, gonna be this 0 instead of 9. Yeah. So finally, we're gonna return the final result. So we're gonna call the function. It's gonna be 0 index and 0 mask, and the is limit we're gonna set it to true. If we set it to false, how can we make it to true from here? This is why we have to set it to true, because from here we're gonna always use it. This is limit and d equal to the high. And here I forgot about the last one, is num, as we've already choose a number. Yeah, because for here this means we're gonna choose a number, choose a digit. So from here this is num gonna be true. Yeah, because we choose a digit here, not choose digit. Yeah. So for the last one, as we are not choosing, so it's gonna be false. So finally, we want to call the function. Yeah, I've already called. Yeah. Now I just wanted to check if it works. Yeah. Let me think about here. So here, not choose a digit. If I not choose a digit, this one would be true. So for example, it is still 20 in this example. For the first one, we didn't choose a digit. So this means the is limit gonna be true because we can choose a 9. Let me think about it. Yeah, let me think about here. Yeah, for the first digit, if we didn't choose it, so after that we can choose 1 to 9. We can choose 1 to 9. It is okay. So this means its limit gonna be true. Yeah, because for the first position we didn't choose a digit, so after that definitely we can choose the highest 1 to 9. Definitely we can choose it. Yeah, because that gonna be smaller than this number 20. So for this number 20, for the first position we didn't choose it. And then what are we gonna choose? We cannot choose 0, but we're gonna choose 1 to 9, and 1 to 9 gonna be less than or equal to 20. So definitely, so here we're gonna set it to true. Now let me just check if it is okay. I think it should be okay, but let me just run it. Oh, it didn't work. Let me think about it. Yeah, here I did something. Let me think about it. The its limit gonna be false. Yeah, I think I did something wrong. Yeah, because if I can choose 1 to 9, definitely it is a false, because if it is false, I can choose 9. Yeah, I think I made a mistake. I should not change it. After change it, definitely it is a mistake. Now as you can see it works. Now let me just submit it to check if it can pass. Yeah, as you can see it passed for all testing cases, and it's pretty fast. Because the time complexity is dependent on this I and mask. The mask is just for numbers from 0 to 9. So basically it is a 10, and the I gonna be the length of the n gonna be 10 to the power of 9, so it is another 10. And for this one, its num and its limit is just Boolean values. It can be 2 and 2 if we wanna analyze the time complexity. So basically the time complexity is just 100. That is why it's so fast. I think that's all about it. Thanks for watching. See you next time.